Hello students. Today we are beginning sequence and series. Before this sequence and series, I take you to your back to class 10, where you must have studied a series called AP or Arithmetic Progression. What did you learn in Arithmetic Progression? Your series was something like A1, A2, A3, and so on, AN, right? And what did we learn? That two consecutive term, they had a difference of D. For example, A2 minus A1 was D. Similarly, A3 minus A2 was D, and so on. So this was your AP. Now, similarly, let us devise a mechanism. For example, suppose we have a series and its expression we write as A1 plus A2 plus A3 and so on plus AN. Then we can represent this from sigma notations like what? K is equal to 1 to N, and then we can write AK. Such a series can be written like this. Now let us say, through few illustrations, let us understand. Suppose I say there is a term AN which is written as 2n plus 1. Now let us say we want to write first three terms. Suppose you are asked, write first three terms. So how would you write? So you'll say, okay, let's take n is equal to 1. So what would I get? A1 as, now replace n by 1. So 2 times 1 plus 1, we will get 2 plus 1, or we will say 3. Similarly, if I say n is equal to 2, I would get A2 as 2 times 2 plus 1, or I would say 4 plus 1 as 5. Similarly, n is equal to 3, I would get A3 as 2 into 3 plus 1. And what would I get? 6 plus 1 as 7. So what are my first three terms? Our first three terms are 3, 5, 7, which are my A1, A2, A3. Let us take yet another question. Say AN is equal to n minus 3 upon 4. And if you similarly find out what is your A1, A1 will be 1 minus 3 upon 4. So minus 2 upon 4 equal to negative 1 upon 2. A2 would be 2 minus 3 upon 4 minus 1 upon 4. A3 would be 3 minus 3 upon 4, 0 upon 4, or simply 0. So we got three terms, A1, A2, and A3. Similarly, we can have plenty similar questions. Let us say we take yet another question. Say, let the sequence AN be defined as follows. हम क्या कह रहे हैं? A1 is equal to 1, And an would be an minus 1 plus 2 for n is greater than or equal to 2. Remember, here it is n minus 1. Let us understand that we are asked to find first 5 terms, and write corresponding series. So let's try to do this. So what will be my A2? So I will get A2 minus 1 plus 2. Then what is it that my answer? A1 plus 2. So it will be 1 plus 2, it will be 3. Okay. Then we find A3. A3 will be 3 minus 1 plus 2. So we will say A2 plus 2. So it will be 3 plus 2, which is 5. And similarly, A4 क्या होगा? A4 minus 1 plus 2. We would say A3 plus 2. We would say 5 plus 2, which is 7. And finally, if we want to find A5, what would be A5? A5 would be A5 minus 1 plus 2. So it is A4 plus 2, which is 7 plus 2 is 9. So we got all the terms. So what is my corresponding series? So 5 term sequence is 5 terms sequence is, what would you write? 1, 3, 5, 7, 9. Okay. And the corresponding series is 1 plus 3 plus 5 plus 7 plus 9 and so on. This is the corresponding series. So hope you must have understood this technique. So you can solve many more problems like that. Let us now understand another series, what is called as geometric progression, or we call it GP. So how does this GP look like? Let's write down the various terms. Let's say it is A1, A2, A3, A4, and so on. Okay. Now here the condition for this is that the ratio A2 upon A1 equal to A3 upon A2 equal to A4 upon A3. Okay, and so on. So we will call it as common ratio R. Now if we say that A1 equal to A, then what would be my series? My series would be, let's say A2, what will happen? A2 upon A would be R. So A2 would be AR. Similarly, if I want A3, A3 will be A3 upon A2 is R. Therefore, you can say A3 is A2 times R. A2 times R, which is AR into R. Then it is known as AR square. Similarly, A4 would be AR cube. Likewise, if we continue with this, then we can find AN, which is AR n minus 1. So what is my GP? Now my GP is A, AR, AR square, AR cube, AR4, and so on. And the last term is AR n minus 1. So we call it AN, meaning nth term, as AR n minus 1. Let us remember it as a formula. Okay. Now let us understand another thing. Now that we know the general term, how to find sum of such a GP. So what is our interest? Let us say I want sum as Sn. So how do I denote Sn as? A plus AR plus AR square plus AR cube and so on plus AR n minus 1. Let me write down as R times Sn. So मैं क्या कर रहा हूं? ऊपर वाले टर्म में R से मल्टीप्लाई कर रहा हूं. And instead of writing it right below A, I would not write. Instead, since I would multiply R by A, so I'll get R multiplied by A, I'll get AR. So I'll not write here. Instead, I'll write here, AR. The next term would be AR multiplied by R would be AR square. And then AR cube. And then obviously you will write the last term as here ARN. Here you will get ARN minus 1. Now what do we do? Let me subtract it. Minus, then this would be minus, minus, and so on. So what will I get? Sn minus R times Sn equal to A, and this would all get cancelled. Okay, so A minus ARN. Now here, take Sn common, 1 minus R, and then A, 1 minus R power n. So Sn would be A 1 minus Rn upon 1 minus R. Now remember here that R should be less than 1. Okay. Now if you do one more thing, that Sn can also be represented as, if you take minus common, it would be Rn minus 1 upon, again take minus common, and it will be like that. So you can cancel this, and then you would get A Rn minus 1 upon R minus 1, and n should be, here what you should do, R has to be greater than 1. Remember, if R is equal to 1, then Sn becomes indeterminate or undefined, because R minus 1 would become 0. Okay. Then, or indeterminate, we can also say indeterminate. So we got this formula. Now one more thing that we can possibly see is that, what if we use this formula to find S infinity? Meaning if n tends to infinity, so what we get? If n tends to infinity, then my Sn becomes S infinity. So what? As Sn becomes infinity, as Sn becomes infinity, then let us also discuss, since R is less than 1, which means as n tends to infinity, R ki power n will tend to 0. So since then it would become A 1 minus 0 upon 1 minus R. Hence,